and theta I. Okay, this means theta 1 to theta r. Okay, so if we adding and dividing this both term, because this is a finite one. Okay, so this can be written as in this form theta 1 upon you can write here theta of theta I when I is 1 to r. This is x1 plus if we write is and similarly, the last term is theta r summation over this is theta I equals to 1 to r, and this is xr. Okay, so now this term can be reduced into this form. This becomes I equals to 1 to r, and this is theta I, and this is theta 1 upon this is any scalar one. Okay, and if we write this another scale because this because two, the last one is suppose xr. So what is the value of your here alpha I? Alpha I is basically theta I over summation of that theta I. I is varies from 1 to r. This is so theta alpha I. Okay, so now we can write this in this form theta I. Okay, and this can be written as summation over I equals to 1 to r, and this becomes alpha I xi. Okay, and this is the because each for each term theta 2 becomes any finite real number. So that's why here alpha 1, alpha 2, alpha 3, up to alpha r is also a real number. Okay. So this can be written as a linear combination of that, and here each alpha I is greater than or equals to 0. So this means you can write this form is in another form. This equals to 1 to r theta is the linear combination of that. You can write this in any form of y. Okay, so here we can write what is your this y. So y is the linear combination of this I r alpha I and xi. Okay, so now what is the value of summation I equals to 1 to r plus 1 theta I xi. So this equals to you know that I equals to 1 to r is theta I xi and plus theta r plus 1 and x r plus 1. Okay, so here this value summation of this is equals to this summation I equals to 1 to r. This is theta I and y, and this plus theta of r plus 1 x r plus 1. Okay, and here what is your y? So y is summation over I equals to 1 to r alpha I xi. What is alpha? Alpha I is theta I over summation theta I, where I is 1 to r. Okay, so what is here? I is varies from 1 to r. Okay. So you can express this term. This is what is the value of this summation theta I xi when I varies from 1 to r plus 1. So you can write this in this form. Okay. So you have to take the functional form of that, because in left hand side f of this term we take we apply the functional on this. So this equals to this thing. So in next page. So uh, okay, so if y equals to this thing, which is a linear combination of that, So here y is also belongs to that convex set C. Okay. So therefore you take f of this I equals to 1 to r plus 1 theta I xi. This equals to the right hand side f, and you can write here this equals to summation of I equals to 1 to r theta I y plus theta r plus 1 x. So you know that is any scalar one, any function y. Okay, so this is scalar. You know that any if we apply f of any alpha x beta y, know that this is always less or equals to this scalar multiplication, this of this scalar of r plus 1 f of x r plus 1. Okay, so this is to summation I equals to 1 to r theta r, and here f of summation over I equals to r 1
सर आवाज नहीं आ रही आपकी
सर
क्लियर।
आपकी वॉइस ब्रेक हो रही है।
ओके वॉइस क्लियर नहीं आ रही। ओके तो सब नेटवर्क की फिर इशू हो सकते हैं। ओके मैं देखता हूँ क्लास में। ओके जस्ट वेट। Okay, so this equals to summation I equals to 1 to r theta I, and here you know that f is convex function, and this function, this condition holds for at m equals to r. If m equals to r is true, so we apply this formula here. So this becomes you can write this in the form of summation I equals to 1 to r alpha I f of xi, because this condition true for I equals to r. Okay, and this plus theta of r plus 1 f of x r plus 1. ये आपने यहाँ लिख दिया since I equals to r, this is true. Okay, so this implies you can write this f in this form. So this equals to summation I equals to 1 to r theta I, and here what is the value of summation of alpha I? So you know that this equals to summation of I equals to 1 to r, and what is alpha I? Alpha I is theta I over summation over I equals to 1 to r, I equals to 1 to r. This is theta I. This is the function form f of xi plus theta r plus 1 f of xr plus 1, because here alpha I is equals to theta I over summation of theta I varies from 1 to r. That's why you can write this form. Okay, so this equals to This and this are cancelled out, so this is basically I equals to 1 to r theta I f of xi plus theta of r plus 1 f of r plus 1. Okay, so now this equals to, you can write summation I equals to 1 to r plus 1. This becomes theta I f of x I. Okay, so here you can write, this implies f of summation I equals to 1 to r plus 1 theta I xi, and this is lesser equals to, this is lesser equals to this term. This term is summation I is 1 to r plus 1 theta I f of xi. Okay, so this theorem is proved by mathematical induction. This theorem is true for r equals to plus 1. So this implies this is true for n equals to r plus 1. So hence you can say that the theorem is proved by mathematical induction or method of induction. Okay, so this is true. So you can say that for any value of n, this condition, this relation is true. Okay, so the next theorem on next page, so this says that uh, necessary and sufficient condition, necessary and sufficient condition necessary and sufficient condition that a function f, necessary and sufficient condition that a function f defined on a convex set suppose C in Rn is convex, is that a function the just wait. So the necessary sufficient condition that a function f defined on a convex set C in Rn is convex is that the one-dimensional function suppose phi, which is defined as phi of theta, this equals to f of theta x1 1 minus theta x2, okay, where x1 and x2 belong to that set. Or either you take x and y or x1, x2 belongs to C. Okay, is convex. This is convex. This function is defined by this formula. This is convex on the closed interval 0, 1. Okay. So this is the theorem. So here we have to prove that the necessary part and then sufficient part. Okay. So here, first of all, we assume that this function phi be a convex function, and we try to prove that this f is convex. Okay. So first of all, we take this phi be a convex function. We assume that this is convex function, convex function on this closed interval. Of course, this 0, 1 will also be a convex set. Okay. So this phi is convex function, and we have to prove that this f is our convex. And the worst part, if f is convex, then we have to prove that this phi is convex. Okay. So if this is a convex function, then for any theta, then for any theta which belongs to 0, 1, for any for for any theta which belongs to 0, 1, you have f of, you have to find what is the value of this theta x1 convex combination of these 2 points. Okay, so this equals to, you know that if this phi theta is defined by this formula, so what is the value of this? This equals to simply phi of theta. Okay, and phi of theta, you can express this phi of theta as phi of, you can write this theta as theta into 1, and plus you can write 1 minus theta into 0. Okay, why we can write this form? Okay, here this theta can be written as theta into 1 and 1 minus theta. So this theta can be written, because this is the 0 and this is theta into 1. Okay, so here you know that this phi be a convex function and which lies between 0 and 1. So this 0 and 1 be a point on that convex set. So that's why we can design this theta in this form. Okay, so you know that since this f phi be the convex, since phi is convex function on this interval 0 and 1, that's why you can write this is equals to phi of this theta into 1 plus 1 minus theta to 0. This can be written as less or equals to 1 theta into functional value, that is phi at point 1, and 1 minus theta phi at this value at 0. Okay, so what is the value of phi 1? Okay, what is the value of phi 1? If you put here theta equals to 1, okay, here you know that what is the value of phi of theta? Phi of theta is f of theta x1 plus 1 minus theta x2. What is the value of phi of 1? This means we put here theta equals to 1. So theta equals to 1, this is simply f of x1. What about the theta of equals to 0? What is the value of 0 here? This is f of x2. Okay, so that's why if we put here this value is theta, what is the value of phi 1? Phi 1 is f of x1. And this is 1 minus theta. What is the value of f phi of 0? This is f of x2. Okay, so this means this value is equals to this thing, less or equals to this thing, and here you can write this f of theta x1 plus 1 minus theta x2. So this equals to this thing, and this is less or equals to this thing. So this is less or equals to theta of fx1 plus 1 minus theta of fx2. Okay, and this holds for any x1, x2 that belongs to that set C. Okay, so this implies this holds. You can write this condition. This holds for all x1, x2 that is the element of that convex set C, and hence so F is convex on set C. Okay, so here you take this phi which is convex on this 0, 1, and you are able to prove that this function f, this function f, here you take here x1, x2 belongs to C, and you take this form. Okay, so you are able to prove that this f is convex one. Converse part, if you suppose that if this f is convex, which is defined on that set C, okay, then we can prove that this phi is your convex function, which is defined on this 0, 1. Okay, so if this means we take any theta 1 because this phi is function of theta. So if we take any theta 1, theta 2, which belongs to this 0, 1 interval, okay, and if we are able to prove that the convex combination of that, so say if we take any alpha parameter which lies between 0, 1, okay, and we are trying to prove that this alpha of theta 1 plus 1 minus theta 2 of alpha 2, the phi of that image is less or equals to that thing. So this means phi is your convex function. Okay. So converse part, on next page, we prove that the converse part. On next page, conversely, suppose that this f is convex on this convex at C. Okay, so then for any theta 1, theta 2 that are the element of this closed interval 0, 1, and we have to prove that this phi of the convex combination of, suppose we take another parameter alpha, and this point is theta 1 plus 1 minus alpha theta 2. Okay, we have to prove that this thing here alpha is lies between 0 and 1. Okay, and this theta 1, theta 2 that belongs to 0, 1, and this is a point basically. This theta 1 and theta 2 are points. Okay, so here we take the honest combination of these two. So this equals to what is the value of this term phi of theta. Okay, so here you know that phi of theta, this is defined as f of theta x1 plus 1 minus theta of x2. Okay, so if this is theta, so we can write f of this form. So here this theta is this thing. So here this is your theta. This is your theta. So you can write this in the form of f, okay, and here this is whole theta of x1. This means what is your theta? Your theta is this term, this alpha theta 1 minus alpha, okay, theta 2, this into x1. You can write here x1. And plus the next one is 1 minus theta. So 1 minus this theta. Theta is alpha theta 1 plus 1 minus alpha theta 2. Okay. This sorry, this into x2. You can write this into x2. Okay, and what is x1, x2? So x1 and x2 are belongs to set C, and what is your alpha? The alpha is lies between 0 and 1. Okay, so here we now simplify this term. This term. So this term equals to okay. So this equals to f of okay And if we multiply here, it will become alpha theta 1 x1 plus 1 minus alpha theta 2 x1. Similarly, if we multiply here, this becomes x2 minus alpha theta 1 x2 minus 1 minus alpha, and this is theta 2 x2. Okay, so we can write this thing. So now, if you take f of here, this first term is alpha theta 1 x1, and here if we multiply this term, so this becomes plus uh, or minus this alpha के साथ अगर हम ले लें, तो this becomes alpha okay. So now we recombine this term. Okay, so first of all, we take this theta 1 x1 term here and theta 1 x2 term here. Okay, इन दो term को अगर हम एक साथ combine करें, so this becomes theta 1 x1 and here minus theta 1 x2. Theta 1 x2. Okay, and if we adding some term, that term is x2 alpha and minus x2 alpha. Okay, so this term is additional term. Okay, this term are additional term. We are adding and subtracting these two terms. Okay, then plus the remaining terms are this thing. The remaining terms are, if you take 1 minus alpha is common here, so you can or you can simply write here 1 minus alpha. In next line we take the common and so on. And here this is minus of okay, minus of 1 minus alpha theta 2 x2. Okay, so now this equals to f, and here we take this term alpha of theta x1. If you take alpha theta 1 x1, and if we take
x2 टर्म तो रहेगा ना,
कौन से कहाँ पे
प्लस x2 तो रहेगा ना,
ये टर्म लिखा
उसी लाइन में,
ओके
उसके नीचे वाला लाइन. हाँ,
ओके x2 term is missing here, so we can write here x2, so here plus x2 and then so on. Okay, now is it correct? Okay, so now if we take this term alpha of x1, this term, and 1 minus theta 1, if we take this term and x2 alpha is common, तो okay, तो हम अगर इनको एक साथ ही लिखते हैं, okay, this plus x2, and here we can write alpha of x1, and next term is x2 alpha. If we adding this plus x2 alpha and minus this alpha theta 1 x2. Okay, this is we take this term and this term. Okay, we take this together here. This is blue line. Okay. Remaining terms are written as in this form. So plus, if we take 1 minus alpha, and this is theta 2 x1, and minus 1 minus alpha theta 2 x2, and this term is your x2 is term and your minus of x2 alpha. Okay, so this is this remaining terms. Okay, तो हमने इनको एक साथ लिख लिया और इन बाकी सबको एक साथ लिख लिया. So now this equals to f of, हमने फिर अब रीअरेंज करना है हमें थोड़ा, तो we take alpha common, so this becomes theta 1 x1, and here if we take 1 minus theta 1 is common, so alpha x2, so this becomes x2 alpha. Okay, if we take from these two, plus here 1 minus alpha, 1 minus alpha, and here x2 x1, here minus of 1 minus alpha, uh, x theta 2 x2, and here we take 1 minus alpha from these two, this is x2. So this equals to f of, if we take so this is 1 minus theta and this is alpha. Okay, so if we take alpha is common from these two, so this equals to theta 1 x1, this is theta 1 x1 plus 1 minus theta 1 x2 if we take alpha common. Okay. Plus similarly here if we take 1 minus alpha common, 1 minus alpha is common, it becomes theta 2 x1 minus theta 2 x2, and here plus x2. Okay, so now this becomes f of, if we take alpha, and this is theta 1 x1 plus 1 minus theta 1 x2, and here plus 1 minus alpha, and this is x1 and x2. If we take theta 2 x1, this is theta 2 x1 plus 1 minus theta 2 x2. Okay, so finally we get this notation. Okay, so now this phi equals to this thing, and f be the convex function. F is your convex function. Okay, and here you know that f is convex function, and theta 1 x1 plus 1 minus theta 2 x2, because what is the value of this function? Okay, so you know that this x1 and x2 which belongs to your c1 and c2. Here x1 and x2 belongs to c. Okay, and theta is lies between 0 and 1. They lie between 0 and 1. This means the convex combination of these 2 points is also belonging to that set C. Okay, so this means this is belong to C, this is belong to C. Okay, and f be the convex function, and alpha is lies between 0 and 1. So that's why this is convex function. So you can write this. हम यही कर देते हैं. इसके नेक्स्ट इसके आगे. Okay. So this means your value is this phi of alpha theta 1 plus 1 minus alpha theta 2, and you can finally, this is same as f of this alpha theta 1 x1 plus 1 minus theta x2 plus 1 minus alpha theta 2 x1 plus 1 minus theta 2 x2. Okay, and since this function is f is convex, so this implies f is convex, which is equals to, this is less or equals to alpha times functional value at this point. This point is theta 1 x1 plus 1 minus theta of x2, and plus 1 minus alpha of functional value at this point. This point is because x1 and x2 belong to C, and the convex combination of these 2 points also belongs to C, because C is the convex set and f is the convex function. That's why the scalar numbers are outside from this function. Okay, so this becomes this plus 1 minus theta 2 of x2. Okay, so this equals to alpha, and what is the value of this f of theta 1 x1 and f theta 2 x2. Okay, so we have to find what is the value of this. Here we look here what is the value of, if this is theta x1 plus 1 minus theta x2. If we take here theta 1, this here theta 1, so this value is phi of theta 1 from the definition. Okay, and this plus 1 minus alpha, and here from definition this is phi of theta 2, phi of theta 2. So this means you can prove that this phi of alpha theta 1 plus 1 minus alpha theta 2, this value is less or equals to alpha of phi of theta 1 plus 1 minus alpha phi of theta 2. This means this phi is convex. So this implies to say that hence your function phi theta or phi is simply phi is convex on given set 0. Okay, so here you can prove this thing. Okay, तो इस तरह से आप इसकी प्रूफ आप कर सकते हैं, थोड़ा लेंदी प्रूफ है. ओके, सो नेक्स्ट वन, any quadratic form is convex if and only if the quadratic form में आपको जो मैट्रिक्स मिलेगी, that matrix is, that symmetric matrix is positive semi-definite. Okay, तो next proof है कि हमारा जो कोई भी quadratic form होगा वो हमारा convex होगा if and only if the matrix B is our positive semi-definite. Okay, तो ठीक है, आज तो 2 बज गए हैं. आज के लिए इतना ही करते हैं. मेरे ख्याल से आप भी थक गए होंगे 2 घंटे में, तो आज के लिए हम इतना ही करते हैं. नेक्स्ट हम आगे नेक्स्ट क्लास में हम इसे करेंगे. तो आज के लिए इतना ही करते हैं. हाँ हाँ
सर, सर बुक के बारे में कुछ बोल दीजिए.
बुक तो आपके जो सिलेबस दिया है उसमें ऑलरेडी बुक्स मेंशन हैं, और कुछ बुक्स और भी होंगी तो मैं उसको आपके ग्रुप में मैं डाल दूंगा. पीडीएफ फाइल मिलेगी. मैं डिपार्टमेंट में यदि जाऊँ तो हमारे सिस्टम में है, डिपार्टमेंट में बुक्स हैं कुछ जो है. तो वैसे भी अगर आपको पढ़नी है तो आप बेसिकली कॉन्वेक्स एनालिसिस आपको पढ़नी है तो पहले, और देन ऑप्टिमाइजेशन पे जाना है. तो हमें बुक्स तो एक नहीं है, कई बुक्स हैं उसको हमें कंसल्ट करना होगा. तो आप कॉन्वेक्स ऑप्टिमाइजेशन की बुक है स्टीफन बॉयड की, दैट इज अ रेफरेंस बुक. ओके, फॉर रिसर्च ओरिएंटेड बुक है वो. आप स्टीफन बॉयड आप देख सकते हो, गूगल पे आपको मिल जाएगी स्टीफन बॉयड. और भी आपको चाहिए तो लीनियर प्रोग्रामिंग ऑप्टिमाइजेशन जब हम कराएंगे तो वहाँ पे आप जेके शर्मा और एडविन चौंग की बुक ले सकते हैं. और जब न्यूमेरिकल कराएंगे तो उसमें भी मिलेंगे. और ये तो पूरी एनालिसिस है, कॉन्वेक्स एनालिसिस की. आप कोई भी बुक आप देख सकते हो, तो आप गूगल पर डालेंगे तो ऑप्टिमाइजेशन टेक्निक्स की बुक आपको मिल जाएगी. तो कई बुक्स हैं, और ये सब जो भी स्टार्टिंग चल रहा है ये स्टीफन बॉयड में आपको ये सारी चीज़ें मिल जाएंगी. थोड़ी थोड़ी, पूरी तो नहीं मिलेंगी. उसमें स्टेटमेंट
सर एक बार सर व्हाट्सएप पे लिख दीजिए सर. अरे ना
ओके, वो आपका जो सिलेबस है, जो सिलेबस दिया है ना उसमें नीचे तो स्टीफन बॉयड लिखा हुआ है, आप उसमें देख लेना. सिलेबस में जो सिलेबस है उसमें आप नीचे देखेंगे तो स्टीफन बॉयड कॉन्वेक्स ऑप्टिमाइजेशन बुक मिल जाएगी. तो उसमें आपको पूरी कंप्लीट प्रूफ्स इस तरह से नहीं मिलेंगे, उसमें स्टेटमेंट मिलेंगे. प्रूफ तो हम करा रहे हैं आपको, बट वहाँ पे आपको स्टेटमेंट मिलेंगे. तो आप प्रूफ यहाँ से देख लीजिए, वो बुक पढ़ लीजिए. और वो सॉफ्ट कॉपी मिल जाती है, अवेलेबल है सॉफ्ट कॉपी. ठीक, तो इतना ही करते हैं आज. हाँ, आज काफ़ी लंबा हो गया 2 क्लास. ओके, नेक्स्ट क्लास हम थर्सडे करेंगे. थैंक यू.
थैंक यू सर.
थैंक यू सर. थैंक यू.